Hello, everyone. Welcome to discussion 2. We are going to be doing an introduction to Java. And just so you know, there is no discussion 1. You didn't miss anything. It's just week 2, discussion 2. This is how we're doing it. So yeah, today, hopefully you've already seen some hands-on experience with Java through doing the lab and Project Zero, but we are going to just hammer in some of those more important details and hopefully get you more comfortable with this whole thing. And announcements for this week, Lab 1 is due this Tuesday. I think this video will actually get posted Wednesday, so that already passed. Project Zero is due this Friday. Lab 2 is also due this Friday. Office hours start this week, and read the ed guidelines before making posts because some of our rules have changed. All of these announcements and more can be found in more detail on ed in the weekly announcements post. And hopefully you have all read that because you have to. And that's it for announcements. These slides can be found on the website, as can everything else. You probably know that since you're watching this video. And we are going to go straight into the worksheet now. So we're going to start with problem 1, our first Java program. So this is our first Java program of the semester. Next to each line, write out what you think the code will do and run. And if you think the line is going to result in an error, correct that error, and then proceed through the code as if it's running your corrected version. So I'm going to give you a moment to pause the video, look at this, try to do it yourself, and think about it, and then we'll come back. So pause. And I'm going to assume you've paused and you're back because you've attempted the problem. So we're just going to go through this line by line, sort of like Java would really do. So first we see size equals 27. Now, does this line work? I say it errors, and it's because in Java, we need to declare the type of our variables. And so when we say size equals 27, Java needs to know what size is, what type of variable size is. And so because it's assigned to 27, we can assume int size 27 would be a sufficient way to correct this line. There are also multiple other number types in Java, such as double, float, etc. But for now, we'll go with int because you're probably most familiar with that. Then we have name equals Fido. So thinking about what we just did in line 1, do you think line 2 is correct? I say again, it errors, and this is because it should be something like this. String name equals Fido. Cool, making some corrections. Now we see dog, my dog equals new dog of name and size. And so assuming that we corrected these lines, so size and name are good variables now, we can actually use them. This line to me looks correct. Assuming there is a dog class and its constructor takes in some name and size variables, which are presumably a string and a number, this line should work. And so we will have a little dog named my dog. He has name is Fido, and his size is 27. And keep in mind, we don't actually know what these variables are called under the hood, but I'm assuming that's the kind of thing that they're pointing to, right? A name and a size. Then we have your dog. It's another new dog. This time instead of passing in variables such as name and size in the constructor, we've just gone ahead and passed in a string and a number themselves. But this still works, right? And so now we have another object, and it's referred to by the variable your dog. And again, we have Scruffy and 1000. That's one big dog. Now we make a dog list using this syntax. Dog brackets dog list equals new dog 3. And so what this does is it declares an array and then initializes it, and it is size 3. And so this means we have this empty array. We haven't put in anything in yet, but it is of size 3. Who knows what will go in those boxes? But that's what this line does. Then the next line, we put something in that array. And so we say dog list of 0 is my dog. And keeping in mind that Java is 0 indexed, meaning these little corner numbers are the indices, we know dog list of 0 is going to be that 0th or first, if you're a human, spot in the array. And so this will point to my dog. Then we say dog list of 1 equals your dog. So far, so good. Now, can we say dog list at index 2 equals 5? I don't think that works because in Java, arrays and everything else can only hold, when I say everything else, I mean like container types, can only hold one set type of variable, object, etc. And so when we say dog list is a dog array, it can only hold dogs. And the number 5, not a dog, unfortunately. And so to correct this line, we could either say maybe dog list 2 equals, and then put in a valid dog instance, such as, I don't know, my dog is named Socks. He's very cute, and he's like 25 pounds. So we'll put that there. We could do that. We could also just delete this line. Either way, we want to get rid of the error. Next, okay, so let's say right here, this is pointing to Socks, my very handsome dog. He is a little white terrier. Okay. And then we have this line. Dog list at index 3 equals new dog with name cutie and size 8. Now take a moment. Does this line work? I say no, because the array doesn't have an index number 3, right? There is no third element. And so this line will result in an index out of bounds error. One way we could fix this would be by simply changing this to a valid index. And then we would actually like sort of overwrite what we did previously, right? Because now it's no longer pointing to Socks. Sorry, Socks. It would be pointing to cutie. The other thing we could possibly do is maybe make this array size 4 to begin with, such that this line doesn't error later on. One thing important to note about Java is that you cannot extend or like expand your arrays. If you declare it to be size 3, it's always going to be size 3. Unlike in Python, you can't do like .append to make it longer. It's stuck that size, and if you want to move to a bigger array, you're going to have to copy the whole array over to a new and larger array. That's that. Okay. And then in the next line, we declare an int x. And so here we are actually just declaring x, not initializing it. But that's okay. That works in Java. You can declare it early and then initialize it to a real value later. And so in line 10, we declare it. Here's where we actually initialize it and give x a value. And we say it is size minus 5. And so assuming that our earlier line was corrected right here, if size is 27, size minus 5 is 22. So x is really 22. And now we say if x is less than 15, we're going to call some dog bark, but it's not. So we skip over this. And that is all of problem 1. Cool. We're now going to move on to problem number 2, mystery. So this is a function, also known as a method in Java, and it takes an array of integers and an integer as arguments. It returns an integer. So we can see all that in the signature here, right? It's taking in an array of ints and an int, and it's returning an int. Now, this is the function, and our first question is, what does mystery return if input array is 30463 and k equals 2? So why don't we take another moment to pause? You can go ahead and do the problem, and then we'll go through it together. Okay, I'm assuming you paused, you're back. I missed you, it's been so long. And we're just going to jump into this. So we will pretend to be Java for a moment. We are going to have our input array 30463 and k equals 2. And we're going to set the code line by line because that's what Java does. So first we say int x equals input array of k. So we're taking k, which here is 2, and going to the second index in our array. And as you recall, Java is 0 index, so it's 0, 1, 2, 3, 4, which means k, or the kth element of input array is 4. So right now we have x equals 4. Then we say answer equals k. Right now, answer is 2 then, because k equals 2. Then we say index equals k plus 1. So index equals 3. Now we say, well, index is less than the input array.length. And so just right now, we're getting a hint that we're going to be probably indexing through the array, and this check will make sure we never go out of bounds, right? If our index is less than the length, we're never going to go over the edge of the array. Then we say, if the input array at index is less than x, so first let's just look at what that would be. So our input array is this right here, and we have at index is 3. So the element we're looking at is 6 because input array of index, which is 3, is 6. If this is less than x, which is 4, then, well, let's not even bother, right? Because we're not going into that yet. We see that 6 is greater than 4. So we're just going to pass over this and we'll increment the index. So now index equals 4. Then again, we go back to the top of the while loop and repeat this. While the index is less than the length, and it's true, 4 is less than the length, which is 5, if input array at that index, so we go back to our input array at index 4, we see the element 3, and so right now this like whole thing right there is evaluating to 3. Sorry, that's kind of squished. And if that is less than x, x is 4. This is true, right? 3 is less than 4. Input array at the index, which is 4, is less than x. Writing all this down will definitely help. Then we say, so we're entering the if statement and we say, x is now equal to that value. And so x will be equal to 3. Then we say, answer equals index. So at this point, answer now equals 4 because index is 4. Then we increment index one more time because we left that if statement. Index becomes 5. And is 5 less than the input array.length? 5 is equal to the input array length. So we exit the while loop and we return the answer. What we end up returning then is, and I kind of erased it here, 4. So this is what it returns. So can you explain in plain English what mystery does? Why don't we take a look at the steps we just took and see if we can figure it out together. We were given an input array and some number k. We looked at the kth element and sort of recorded that as x, right? And then we started iterating through the array from that point k and beyond, and checking to see if the current element was smaller than x. If it was smaller, then we would change our answer to be that smaller element's index. And we went through the whole array doing this from the point k and beyond. Then I think that what this whole function does really is you're taking the input array and you're looking to see what the index of the smallest element is after the point k. And so here we can see that we were given 2, right? 3, 0, 4. I'm just writing it out again so we can scribble all over it. We were given the index 2, and the smallest element from 2 and beyond was 3, and the index of that smallest element was 4, which is why we returned 4, right? And so we're not returning the smallest element itself. We're not returning 3. We're returning where we found it. And so just in case this doesn't really fully click with you, if we put in another array, let's say like 5, 1, 2, 3, 7, 8, for example, and let's say we gave it the index 1, it's going to look at the elements 0, 1, 2, 3, 4, 5. So all the elements 1 and beyond, basically this whole subarray, find the smallest element, in this case, it's this one, and return the index of the smallest element, which is 1. And so if we had given it, let's say, the same input array, but instead ask for k equals 4, then it would only look at the elements 4 and beyond, find the smallest element, and return the index of that smallest element, which is 4. And so that's how mystery works. A little odd, I don't know when this method would come in handy, but hopefully it was good exercise in just looking at Java code and understanding what it does. That's a huge part of your job in the real world as a programmer, and it really comes in handy when you can look at like a huge code base and get an idea of what is going on by reading it. And so now we have an extra problem. And so again, I'm going to give you a moment to read the problem description and describe what mystery2 does if input array is 30463, so the same input array as earlier. So let's take a moment, pause that sweet old video, and then we will come back. Okay, I'm assuming you have paused. Took a long gap there because I really wanted you to pause and do it. And so let's just go through this again, line by line. Again, you take in an input array, and so let's say it is 30463. Not sure why my pen changed to black. And we're going to say index is 0. Now, while the index is less than the length, which is true, we say target index equals mystery of input array and that index. And so again, thinking back to what we just said mystery does in plain English, we know if we call mystery with this array and index 0, it is going to look from the 0th element and beyond, which means in this case, the entire array, right? And it is going to find the index of the smallest element. And so here that is 1, right? Because 0 is the smallest element and 1 is the index. So right now, target index equals, oh my God, I spelled that wrong. Index equals 1 because mystery with this input array and index 0 would return 1. Then we say temp equals input array at that target index. So right now, temp is input array at index 1, which is 0. Then we say input array at target index equals input array at index. And so we're basically changing our array, right? And we're saying at the target index 1, we're setting it equal to the input array at index, which is 0. So index of 0 is 3, so we put that in there. Then we increment the index by 1. So I will just go ahead and do that. Now we go back up to the top of the while loop and repeat. The index is still less than the input array length, which is 5. And we say our target index is once again calling mystery, but this time with their index being 1. And so again, mystery will look at the elements 1 and beyond, right? Because mystery of this array, index 1, going to look at this, and we will find the smallest element. In this case, we'll go with the first 3 because I just realized I missed a step. Right here, line 7, input array of index equals temp. So previously index was 0, temp was 0. We should have moved that there. My bad. I caught it though. And so moving on, input array. So we call mystery thus far on this. And we'll say again, the first 3 is the smallest. I don't think the tie breaking really matters. Actually, yeah, and if you go back to mystery, you're going to notice that the way the function works, it's only going to switch them anyways if it was strictly less than. In other words, it's only going to mark the second 3 right here as the smallest element if it were strictly less than the first 3, but it is not. So we know the answer will be 1. And then we say, so target index is still 1. Temp is going to be input array at the target index, which is 3. And then we basically say input array at target index equals input array at index. Really, this line doesn't do anything, right? Because we're saying input array at 1 is equal to input array at 1. Nothing happens. And again, we say input array at 1 equals temp, which is 3. It already was that value. No biggie. And then we say index plus equals 1. Now it's 2. And again, back up to the top of the while loop. So we still pass the conditional. We say our target index is equal to mystery of the input array and 2. And so now we are looking at this subarray of elements index 2 and beyond. And we know mystery is going to look for the smallest element. Here it is 3, and it is going to return the index of that smallest element. So it returns 4. Thus, target index equals 4 because it's equal to the return value of mystery. Then we say temp is input array at the target index. So in our array, input array of 4 is equal to 3, and so temp is equal to 3 still. Then we say input array at target index is equal to input array at index. So input array at index 4 is going to be equal to input array at index 2. So 4 moves here. And then we say input array at index equals temp. And so this becomes 3. And so hopefully we're all seeing a pattern here, right? What we're doing basically is we are going through the array. We're picking out the smallest element one at a time by using mystery, because mystery finds the index of the smallest element thus far. And then we're swapping that with the current element. And we're going through the whole array doing this, looking at the subarray beyond and beyond until we'll eventually reach the end. And so knowing this, we have a feeling when we come up here, we're probably going to end up swapping 6 and 4. And let's just go through it and see to confirm. So index is incremented to 3. We go back up to the top of the while loop. 3 is still less than 5. We say our target index is equal to mystery of input array and 3. So that means we're looking at elements 3 and beyond. Looking at just 6 and 4, we know mystery will turn the index of the smallest element. And so that is going to be 4 because 4 is less than 6 and the index of 4 is 4. And that is what target index is set equal to. So target index is still 4. Then we say temp is equal to input array at the target index. So input array at 4 is equal to 4. Then we say input array at index, which is 3, is equal to temp. Wait, sorry. Input array at target index is equal to input array at index. Skip that line almost. So input array at 4 is equal to input array at 3, which means 6. And then we come in and do this line, setting input array at index 3 equal to temp, which is 4. And that is that. And we will come back up again, and I'm not going to bother stepping through because hopefully you have all caught on to this idea of we are sorting the array. We're going through it, iterating through, each time finding the smallest element, setting it equal to the current and swapping the current out to wherever the smallest was, and doing that for every index until we are eventually done finding the smallest element and putting it in its correct place. And so this is actually an algorithm called selection sort. If you want to learn more about it, we will cover it later in the class, or you could go look it up right now because it's super common and there are lots of cool videos and materials out there that will teach you about why selection sort is so cool. Lastly, we're going to talk about question number 3, writing your first program. So this one, you're going to get a little experience starting to write an actual little algorithm. And so we're going to ask you to implement fib, which takes an integer n and returns the nth Fibonacci number. You might not need to use all the lines. And so if you don't know what the Fibonacci sequence is, it is basically you take the first 2 numbers before you and add it to get the current number. What does that actually mean? Let's show you. The first 2 numbers in the sequence are 0 and 1. The number after that will be the 2 numbers before it combined. So 0 plus 1 equals 1. Then what's the next number? Well, it's the 2 numbers before it combined. So 1 plus 1 equals 2. What's the next number? 2 plus 1 equals 3. What's the next number? 3 plus 2 equals 5. 5 plus 3 equals 8. 8 plus 5 equals 13, etc., etc. And so that is how we get this sequence here. If you are still confused, you can take a moment to look up the Fibonacci sequence before going on to complete this problem. I'm going to give you a moment to pause the video now and try to implement this yourself. So let's pause and play. We are back in business. Hope you had a good time doing this. So how do you go about implementing this, right? My gut instinct is to maybe do this recursively because the definition of Fibonacci is sort of recursive, right? We first know that if there's some condition where you're going to have to reach a base case and stop, but we'll just say we don't need to know. What we do know is that in the normal case, the current Fibonacci number is equal to the Fibonacci numbers before it combined. So can't we just say return fib of n minus 1 plus fib of n minus 2? To me, that looks pretty good. Now the question is, what are our base cases? Well, we know the Fibonacci sequence relies on the two numbers before it, right? So 1 relies on these two. But these two cases, the 0 and the 1, don't actually have the two numbers before it, right? There's not like two things that can add to get here. 0 and 1 are sort of just given as our starting point, and we sort of have to take those into account. So that is our base case. And so we could say, how about if n is less than or equal to 1, then we just return n. And that seems like a pretty clean solution, right? We say if n is 1, the first Fibonacci number is 1, and the 0th Fibonacci number is 0. So it works out pretty cleanly that way. And this solution works. So congratulations if you got here, you're at a working solution. But we can do even better, right? I think we could get a more efficient implementation of this little program. And the reason I say that is because, for one, we're doing a lot of repeated calculations when we do this, right? Let's say we're calculating fib of 5. Oops. From fib of 5, we're going to call fib of 4 and fib of 3, right? But from fib of 4, we're going to call fib of 3 and fib of 2, right? Because fib of 5 equals these. Oh my God, I can't even write all this, right? Like it doesn't fit. And you're going to see that we've calculated just in fib of 5, we calculated fib of 3 twice. We calculated fib of 2, 1, 2, 3 times. And we're going to do fib of 1 a whole bunch and fib of 0 a whole bunch, right? And so it's like, why are we repeating all of this work, right? Can't we do it in a different way? Maybe instead of building from the top to the bottom, rather going bottom up. So we're not like repeating all these calculations. And the other thing to consider is that when we do write our program like this, it's also not space efficient because the first function call, fib of 5, I just realized I erased all my work. Fib of 5 is dependent on the two calls below it, right? And so this call or this function frame can't close or terminate because it's waiting on the two recursive calls beneath it to terminate before it can return its value, right? And so all these function calls have to stay open. They're all waiting on someone below them before they can return. And that is not very space efficient. If you recall tail recursion, which I believe is covered in 61A, this is not a tail recursive program because we have to wait on the function calls beneath us. And so if we could avoid this, then our program would also be more space efficient because we wouldn't be keeping all these functions open. So why don't we try to improve upon this a little and write a more efficient version of fib? So again, I'm going to give you a moment to pause the video, think really, really hard about how we can do this, and then come on back. And here we've given you some more variables you can work with. Think about why these might be helpful and try to incorporate them. Bye. Hi, hope you had a really good time implementing Fib 2. If not, that's okay, because we're gonna go over it. So we know that our first implementation of Fib was okay, it worked, but it wasn't that efficient, right? And I think a lot of the reason to blame is because we were going from the top to the bottom. We were starting at Fib of 5 and going, okay, what was Fib of 4 and Fib of 3? And then from Fib of 4 going, oh, what was Fib of 3 and Fib of 2? And so we're not calculating the Fibonacci sequence in the natural order that it's built in, if that makes sense, right? Because we know that the Fibonacci sequence, you start at 0 and 1, and every number after that follows sort of in this direction, right? Like all the numbers later depends on the one before them. And so it was kind of weird to start at fib of 5 and then go around asking for fib of 3 and fib of 2 before we've calculated them, right? It was like we were always asking for numbers that hadn't been calculated yet, and so we had to go calculate them, and that led to like a lot of repetition, and it wasn't very efficient. When naturally, the way the Fibonacci sequence is defined is by starting at the bottom and working our way up. So why don't we try to do that, right? We'll start with 0 and 1 and then build up until we reach the nth number. And so to me, this is already implying that we are going to start at the 0th number and go until we reach the nth number, right? And so we know that this might suggest if n equals k, that means we've reached the number we're looking for, right? We started at the 0th number, and we will probably increment this until we reach the kth or the nth Fibonacci number, right? So that's our first little thought. Otherwise, though, if we're not there yet, we're going to need to keep building these numbers up, right? And so we might say return fib2. We're doing a recursive approach again because that's sort of how Fibonacci is defined. And we will say, let's see, we're still always going to be reaching for the same number n. K gets incremented, right? Because we are starting at the 0 and progressing through. And here's the important part. F0 and F1. How are we incorporating those, right? Well, we know the nth number is always defined, or fib of n, right, is fib of n minus 1 plus fib of n minus 2, right? And so let's say here we passed in 0 and 1 when we were first calling Fibonacci, right? So those are the 0 and the first elements, right? What is the number after them? Well, it's F0 plus F1, right? That is the second Fibonacci number. And so what if here we passed in the n minus 1 and n minus 2 numbers to the current call? That might sound a little weird, but let's just think about it. If we passed in F1 and F0 plus F1, we see that F1 and F0 plus F1 are sequential numbers in the Fibonacci sequence, right? F0 plus F1 follows F1. And so we're sort of naturally passing in that sequence. And as we progress along, it will build the sequence for us correctly. And then we lastly just have to cover what we do in our recursive base case, right? And so we could say, if we finally reach the end and n equals k, what are we going to return? Well, thinking about it, we're going to want to return whatever was passed in here, because that is sort of thought of as the current number. And so we will just return F0. And so if you don't believe me that this works, you can go ahead and try to run through this code yourself on paper. You will see that what we were doing is basically starting at the beginning. We pass in, well, whenever we call fib2, we're going to have to pass in, the number we want. So let's say 5. Then we're always going to be starting at the 0th element. We're going to be passing in the 0 and first Fibonacci numbers, which are 0 and 1. And so this whole thing will work. You can go try it yourself as a little exercise if you are mistrusting of my information. If you are, my feelings are a little hurt, but not really. You should go try this, and you will see that the program works. And that is all for this discussion. Thank you for coming. Thank you for watching asynchronously in your PJs somewhere else. Who knows where you are. Have a good one.